Hey there, welcome back to another video by Chemical Engineering Life. In this video, we bring to you top 10 emerging job markets for chemical engineers. It's going to be a long video, so sit tight and watch the video till the very end. And if you do enjoy it, then remember to like, share, and subscribe to Chemical Engineering Life channel for more videos. Let's begin. The market that we have at number 10 is chemical safety and regulatory compliance. It is the industry which involves ensuring that chemical processes and products meet the safety standards and regulatory guidelines in order to prevent accidents, protect the workers, and minimize environmental harm. And chemical safety and regulatory compliance have never been more important for the industry than it is now. Because with the industries under the microscope for their environmental impact, workplace safety, and public health, companies are facing stricter regulations than ever before. Agencies like OSHA, the EPA, and other international bodies are pushing for tighter controls, and it is all about keeping people safe and protecting the environment. But what is the main goal here? The main goal is for us to prevent chemical accidents and cut down on hazardous emissions, and to make sure that every operation follows the rules to keep the workers, communities, and our planet safe. And chemical engineers are at the forefront of this industry because they are essential in developing and implementing safety management systems in manufacturing and chemical processing plants. They conduct risk assessments, hazard analysis, and safety audits to identify potential risks in chemical processes. Chemical engineers also develop and update safety protocols, design fail-safe systems, and oversee compliance with environmental permits and ensure that safety regulations are met during the plant operation. And that's not all, because they may even find themselves working closely with the regulatory agencies, ensuring that documentation, reporting, and corrective actions align with the compliance requirements. So the main question is, how can chemical engineers break into this sector? Entering this field requires a solid foundation in chemical process engineering with a specific focus on safety and risk management. Chemical engineers, they need to be well versed in areas such as safety engineering principles, process safety management, and regulatory frameworks like the EPA's risk management plan. At the same time, gaining certifications within Six Sigma, Certified Safety Professional, or Process Safety Management can significantly enhance a candidate's qualification. But most importantly, getting some practical experience under your belt through internships, industrial projects, coursework, or even job training can go a long way in helping you break into this quite competitive sector. The industry that we have at number 9 is personal and household markets. This sector focuses on developing safer, more sustainable products like cosmetics, cleaning agents, and household goods, often using renewable ingredients and eco-friendly manufacturing practices. And quite frankly, this personal care and consumer products industry is evolving rapidly because consumers increasingly prioritize sustainability and environmental responsibility in their purchasing decisions. There is a growing demand for products made from natural, renewable, and non-toxic ingredients, pushing companies to rethink traditional formulations and manufacturing processes. But quite frankly, this shift is not just about going green for marketing appeal. It's about fundamentally changing how products are made to reduce environmental impact. Therefore, the key aspects of this market includes developing formulations that are biodegradable and free from harmful chemicals, as well as optimized processes to minimize waste and energy consumption. And chemical engineers are once again at the forefront of this market because they are heavily involved in research and development, working to create innovative formulations that align with consumer trends and regulatory requirements. Chemical engineers are responsible for designing and testing different products with sustainable ingredients such as natural preservatives and biodegradable polymers. They make sure that their final product meets the performance expectations without compromising the safety of the consumers. Additionally, chemical engineers also focus on optimizing manufacturing processes, streamlining production to reduce water and energy usage, minimizing waste, and implementing closed-loop systems to recycle materials. But most importantly, since these products come directly in contact with humans, chemical engineers are also responsible for ensuring that products comply with the safety and environmental regulations, which involves extensive testing, extensive documentation, and thorough collaboration with regulatory bodies to meet standards like REACH, FDA, and various international guidelines. And if anyone would like to break into this sector, then getting some internships or entry-level positions is a great way to go. It might be a good idea to get positions in companies providing hands-on experience for product formulation, product testing, and process optimization. Additionally, getting certification or short courses in regulatory compliance could also go a long way. But apart from this, there are also quite a few additional skills that can make you stand out in the crowd, such as within data analysis, familiarization with lab testing methods, and also a very good understanding of consumer trends and safety and sustainability. The market that we have at number 8 is circular economy and waste-to-value technologies. This market aims to reduce waste by recycling and reusing materials, turning waste streams into valuable products like fuels and chemicals, contributing to environmental and economic sustainability. Circular economy is a term that we all have heard in the past few years, and it is an emerging framework that prioritizing minimizing waste and maximizing the efficient use of resources, offering a sustainable alternative to the traditional linear economy of take, make, and dispose. Instead, the goal is to turn the linear economy into a closed-loop system where products and materials and resources are continuously recycled, reused, or repurposed, reducing the need for new raw materials and hence minimizing environmental impact. This approach is increasingly critical as industries and governments seek to address global environmental challenges, including resource depletion, pollution, and climate change. One of the most common examples that you see around you is actually of plastic recycling. Chemical engineers have been at the forefront of this technology because they have been responsible for designing methods that can break down plastics and other non-biodegradable materials into their basic chemical components, which can then be used to create new products, effectively closing the loop on material usage. And that's not all, because chemical engineers are also working on waste-to-energy projects where they convert industrial waste into useful energy sources. Also, process design for waste valorization, where they develop systems that can transform waste streams into high-value chemicals or even fuel. In these roles, chemical engineers work directly with life cycle analysis and sustainability metrics to ensure that processes they develop reduce environmental impact across the entire product lifecycle. And if you would like to break into this sector, then obviously you would be expected to have a very good understanding of chemical recycling technologies and waste management principles. A deep understanding of the chemistry involved in breaking down and repurposing complex materials, particularly plastics, is essential for success in this field. Chemical engineers should also develop expertise within sustainable design, which focuses on creating processes and in systems that are energy efficient, low emission, and capable of minimizing waste. Additionally, specialized courses on circular economy practices, including sustainable manufacturing and waste valorization, are highly valuable for building the necessary knowledge base. Certifications within green chemistry or sustainable engineering can further enhance an engineer's qualification, as these certifications reflect an understanding of environmentally conscious process design. Furthermore, collaborating on interdisciplinary teams that includes material scientists, environmental engineers, and economists will be crucial for developing the holistic, scalable solutions that integrate both the technological innovation and economic feasibility. Staying informed on policy trends and regulatory changes related to waste management, recycling, and sustainability will also provide a competitive edge as this field is highly influenced by environmental regulations. And finally, getting hands-on experience through internships or research projects in industries focused on recycling technologies or waste conversion can provide the practical skills and insights into the real-world challenges. The sector that we have at number 7 is none other than digital transformation and data analytics. This market incorporates advanced technologies like AI, machine learning, and data analytics into chemical engineering processes to optimize efficiency, reduce waste, and improve decision making. Digital transformation is literally fundamentally reshaping chemical engineering industry by leveraging cutting-edge technologies like artificial intelligence, machine learning, and digital twins to optimize processes and improve decision making. And this shift allows chemical engineers to move from the traditional methods of trial and error towards a more predictive, data-driven approach. That is because by integrating AI and digital technologies, chemical engineers can simulate complex processes, forecast system behaviors, and identify inefficiencies in real time. This transformation is crucial in enhancing the operational efficiency, reducing costs, and improving safety across industries from chemical manufacturing to energy production. And one of the key technologies driving this change is the use of digital twins, which are literally virtual models of physical processes that provide real-time insights and predictive analytics, allowing for proactive maintenance, process optimization, and greater flexibility in operation. As chemical plants and industries strive to become more smart and sustainable, the incorporation of AI and data analytics is central to achieving these goals. And chemical engineers are once again at the forefront of managing these digital twins, which allow for the continuous monitoring and optimization of chemical processes by simulating real-world scenarios in a virtual environment. Chemical engineers are also using AI and machine learning algorithms to analyze vast amounts of process data, optimizing variables such as temperature, pressure, and reaction times to improve yield and reduce waste. And by leveraging these technologies, chemical engineers can make more data-driven decisions, increasing both the efficiency and sustainability of industrial operations. Additionally, chemical engineers are involved in creating predictive maintenance models where data from sensors and machines are analyzed to anticipate equipment failures before they even happen, hence reducing the unplanned downtime and ensuring smoother operations. Hence, obviously, if anyone would like to break into this field, chemical engineers should have a very good understanding of data analytics, because data analytics is at the heart of this transformation. So proficiency in data processing and interpretation is obviously crucial. Chemical engineers need to develop skills in coding languages like Python, R, MATLAB, or any other language which is required to be able to create the AI and machine learning models. Specialized training that could be done so through courses in data science, AI, and process optimization. Hands-on experience is another key to mastering these tools, so engaging in projects focused on digital optimization will be highly beneficial. Gaining some experience through internships or co-ops at companies focused on digital transformation will obviously provide the practical exposure to these advanced technologies. And obviously, certifications in process simulation software like Aspen, MATLAB, or even R can give you an edge, as these platforms are widely used in industry for modeling and optimizing chemical processes. The market that we have at number 6 is the semiconductors and electronics manufacturing. This involves the production of microchips and electronic components that power devices like computers, smartphones, and advanced technologies such as AI and 5G. And this semiconductor industry is experiencing a rapid growth due to the expanding applications of technologies like artificial intelligence, 5G networks, and advanced computing. These technologies require increasingly powerful and efficient microchips to process data at higher speeds and with even greater precision. And chemical engineers are at the forefront in the area of chip manufacturing because they are driving the innovations in fabrication processes that make the chips more energy efficient and perform highly as possible. Chemical engineers are involved in several key stages of the manufacturing process, which involves converting raw materials into highly complex microchips. They could obviously contribute to chemical vapor deposition, photolithography, the etching process, or any other area that is crucial for the proper production of these microchips. Sure, chemical engineers may require specialized knowledge in order to be able to break into this sector. It might be a good idea to pursue courses in semiconductor manufacturing and material science, which provide a technical foundation for working in this field. Internships in electronics or semiconductor companies can offer the hands-on experience and exposure to cleanroom environments, equipment operation, and the intricacies of chip production. But by doing so, you should be able to break into this sector with ease. But even then, like I said in the very beginning, it is a slightly different sector than the traditional industries for where chemical engineers work. Therefore, you may have to end up competing with other people from electrical engineering, material scientists, even mechanical engineers to be able to find your place. The sector that we have at number 5 is the food and agricultural technology. This industry develops innovative methods to produce sustainable food sources such as plant-based proteins, lab-grown meat, and precision agriculture to address global food security and reduce environmental impacts. Sustainable food production has become increasingly important as the world grapples with food security challenges, growing populations, and the environmental degradation caused by traditional farming practices. Problems such as climate change, deforestation, and overuse of resources have amplified the need for a more sustainable and eco-friendly alternative. And this sector has a major focus on developing these eco-friendly alternatives like plant-based proteins and lab-grown meat. These alternatives aim to reduce the reliance on resource-intensive practices like livestock farming, which contributes to greenhouse gas emissions, a huge amounts of water consumption, and land use. Hence, this market is the need of the hour for a more sustainable food supply chain that can help address both global hunger and environmental concerns. And chemical engineers are once again at the forefront of the development of scaling up of these alternative protein sources and lab-grown meats. They work on optimizing the fermentation processes used to create these products so that they can easily be delivered to the consumers. Chemical engineers may focus on improving the taste, texture, and nutritional content of these products to ensure that they are appealing and healthy alternatives to the conventional foods. For example, for cultured meat, chemical engineers design bioreactors where animal cells are grown to produce meat without the need for any form of livestock. With the help of deep understanding in cell biology, process engineering, and nutrient delivery systems. And therefore, if anyone would like to break into this sector, they need to have a very good, solid foundation in food processing, fermentation technology, and biochemistry. A deep understanding of how biological and chemical processes are used to produce food at an industrial scale is essential. Food engineering courses could possibly provide a strong technical base related to bioprocessing, food safety, and product development. Furthermore, an understanding of regulatory compliance in the food industry is obviously crucial for ensuring that the new products meet the strict health standards and can be safely brought to the market. And finally, getting hands-on experience through internships at food tech companies can really go a long way. The sector that we have at number 4 is the water treatment and environmental engineering. Now, this sector focuses on technologies for purifying water, removing contaminants like microplastics, and treating wastewater to ensure access to clean, safe, and sustainable water sources. Now, as the world is facing growing water scarcity and rising level of pollution, the demand for advanced water treatment and purification technologies has become more critical than ever. This obviously has led to a heightened need for sustainable and energy-efficient methods to help treat and purify water for human consumption, agriculture, and even industrial use. In addition to traditional contaminants like heavy metals and bacteria, there are quite emerging pollutants such as microplastics or endocrine disruptors, which are increasingly being detected in water supplies around the world. And in order for us to address these challenges, we need solutions such as desalination, which is energy efficient, cost effective, and scalable. And that's literally where chemical engineers come in. Chemical engineers are directly involved in designing, developing, and implementing these desalination systems, such as reverse osmosis, which separates salt and other impurities from seawater to produce fresh water. And it is the brains of chemical engineers behind that can allow us to create these systems at a lower operational cost and minimize the environmental footprint. And as you may have guessed, in order to break into this sector, you really need a strong understanding of environmental chemistry, fluid dynamics, and process engineering. Mastering these disciplines is essential for designing systems that efficiently treat water and manage pollutants. You need to be able to get some specialized courses within topics such as membrane filtration, ion exchange, and chemical treatment, and that because they would give you the crucial technical knowledge required in this sector. And apart from these topics, it might be a good idea for you to get your hands on desalination technologies, impact assessment, nanofiltration, environmental regulations, electrochemical treatment, and wastewater treatment systems. This would definitely allow you to get some solid foundation before you enter the sector. The sector that we have at number 3 is advanced materials and nanotechnology. This field designs and creates new materials such as nanomaterials and smart polymers with enhanced properties for applications in electronics, medicine, and manufacturing. And the development of advanced materials, including nanomaterials and smart polymers, is kind of fundamentally changing a wide range of industries from electronics to aerospace to energy. These materials possess unique properties such as enhanced strength, flexibility, thermal conductivity, and electrical performance, making them indispensable for creating innovative solutions. Now, for example, nanomaterials can actually improve the performance of electronic devices by allowing for faster, smaller, and more energy-efficient components. Whereas smart polymers can be engineered to change properties in response to environmental triggers. And once again, chemical engineers find themselves at the forefront because they are the ones responsible for designing, synthesizing, and refining these new materials at the molecular and nanoscale. They tailor the properties of these materials for specific applications, whether it's developing lighter and more durable materials for aerospace or creating biocompatible materials for medical devices. And therefore, in order for anyone to break into this sector, they need to have a very solid foundation within material science, nanotechnology, and surface chemistry. Understanding the behavior of materials at the nanoscale and how surface interactions affect material properties is key to working in this area. Coursework within nanotechnology or areas such as nanoparticle synthesis, nanocharacterization techniques, and applications of nanomaterials is obviously also very essential. But on top of that, you cannot enter this field without having the basic understanding of characterization tools such as X-ray diffraction, scanning electron microscopy, atomic force microscopy, and any other simulation tool that may be required. And finally, getting some hands-on experience or research experience by working at laboratories that focus on nanomaterials, polymer science, or advanced material development could go a long way. The sector that we have at number 2 is biotechnology and pharmaceuticals. Now, this involves using biological processes and organisms to create medical treatments, including vaccines, biopharmaceuticals, and gene therapies, and scaling them up for mass production to improve global healthcare. It's no secret that the biotechnology and pharmaceutical sector has always been a driving force, playing a critical role in developing treatments for some of the most pressing global health challenges. For example, with the demand for advanced therapeutics like vaccines, biopharmaceuticals, or gene therapies continuing to rise, this sector is essential for developing life-saving treatments that can change the course of public health. And the recent pandemics have highlighted the importance of rapidly developing and scaling up these vaccines, underscoring the need for efficient and scalable chemical production methods. And that's exactly where chemical engineers come in. Chemical engineers are responsible for scaling up these production processes to ensure that therapies are accessible and affordable worldwide. Additionally, chemical engineers are responsible for the design and optimization of bioreactors, for example, which can be used to cultivate the cells for microorganisms that produce the desired biological product. These bioreactors must operate under precise conditions to ensure optimal yield and quality. You will also find chemical engineers working directly to optimizing cell culture processes, improving the growth environment for cells used in biopharmaceutical production. And most importantly, since once again it is a highly regulated sector, therefore, chemical engineers must know how to comply with regulatory standards, especially with the Good Manufacturing Practices or the FDA regulation. And chemical engineers, as their core role, is also converting, scaling up lab-scale processes to industrial levels, bridging the gap between research and large-scale production. This obviously involves the most basic fundamental chemical engineering knowledge, which allows them to increase yield, reduce cost, and ensure consistent quality. In order for anyone to break into this sector, on top of your chemical engineering knowledge, you also need to possess a strong understanding of bioprocess engineering in areas such as fermentation, downstream processing, or cell culture is quite crucial. You also may need to be familiarized with fermentation technology, where microorganisms are used to produce drugs or biologically active substances. And since it's a regulated environment, therefore knowledge of the regulatory frameworks, especially GMP, the FDA regulations, is critical for working in this area. And let's not underestimate the importance of gaining some practical experience through internships in biopharmaceutical companies, where chemical engineers can work on real-world problems in drug development and production. And finally, the market that we have at number 1 is none other than sustainable energy and green technologies. This industry focuses on developing clean and renewable energy sources such as hydrogen, improving energy storage technologies like batteries, and capturing carbon dioxide emissions to reduce environmental impact. The global push for net zero emission has made the development of sustainable energy solution more critical than ever. Because as climate change is accelerating and the need for clean energy grows, industries are trying to move away from fossil fuels towards renewable and low carbon energy sources. And there are 3 key technologies where chemical engineers are giving their 2 cents. The very first one is hydrogen production, which is emerging as a clean fuel alternative for various sectors. And chemical engineers are responsible for coming up with designing and improving methods such as electrolysis, where electricity spills water into hydrogen and oxygen. Another topic is battery storage systems, which is especially relevant for electric vehicles and grid storage for ensuring that energy security and stability. In the battery sector, chemical engineers are working on enhancing the performance of energy storage devices by optimizing battery materials and focusing on improving energy density, longevity, and reducing the environmental impact of battery production. And last but not least, there's also the carbon capture and utilization, which allows industries to trap and repurpose CO2 in order for us to reduce emissions from the existing fossil fuel-based infrastructure. Chemical engineers are deeply involved in scaling up these carbon capture technologies, designing systems that efficiently capture CO2 emissions from industrial plants and power stations and convert it into useful chemicals, fuels, or even building materials. And obviously, breaking into this field requires a mix of specialized knowledge and practical experience. Chemical engineers may be expected to have a strong background in electrochemistry, thermodynamics, and catalysis to understand the fundamental processes driving hydrogen production, battery technologies, and carbon capture systems. Also, skills in process simulation and modeling, including Aspen Plus, COMSOL, MATLAB, are crucial for process simulation and lifecycle analysis. And at the same time, getting some specialized training within renewable energy systems, sustainable energy engineering, advanced materials for batteries, or even carbon capture technologies could really set you apart from the crowd. And that was all for this video. I really hope that you enjoyed and learned something new about the emerging technologies for chemical engineers. And if you agree or disagree, then do remember to tell us in the comments below. And also do not forget to like, share, and subscribe to Chemical Engineering Life channel for our next videos. And also visit our website at www.ChemEnggLife.com, where you can learn more about our initiatives such as our mentorship program, our podcast, and everything else that we are doing for bringing chemical engineers together around the globe. Thank you and have a great day.